Okay, good. So today we're going to look at section 1.6. Essentially, we're going to look at different types of equations. We've covered linear ones, we've covered quadratic ones. We have looked at applications, we've done distributive property, we've done clearing fractions. Now we just want to look at different types of equations that are not linear or quadratic, but they're kind of sort of maybe just a little bit the same. So we kind of group them all together. So let's see. First off, suppose we have this. 2 over x plus 3 over x equals 5. I want to solve that out. How is this different from the problems we've done so far? We have done problems with fractions before, right? So how is this different?
In the problems with fractions, the x was almost always on top.
So far, the ones we've done, anytime we had fractions, the x's were on the top. Here we have fractions, but the x's are on the bottom. But ultimately, the goal is still the exact same, solve for x. Then the question becomes, how do we actually do it? When we had fractions before, what did we have to do? Common denominator, and then do what? Multiply by it, right? I think we called it clearing fractions. Find the LCM, the common denominator, multiply by it, and then all the fractions go away. Yes? Good. What's the common denominator here?
X.
Denominator is x and x. The common denominator is x. So multiply everything by x. I am aware at this point you can probably simplify all this out in your head, but again, for completeness sake, in case anybody's confused, I'm writing it out long form and solving it step by step. X times 2 is 2x over x, plus x times 3 is 3x over x, equals 5 times x, which is 5x. Now, reduce your fractions. Your fractions have to reduce. This is no different than solving with fractions before. Multiply by the LCM, fractions have to go away. The x's cancel here, you get 2, plus the x's cancel here, you get 3, equals 5x. And now that's a regular equation, solve it. 2 plus 3 is 5, we get 5 equals 5x. Solve for x, divide by 5, and you get x equals 1. Nice and simple and easy, right? Are we done? Did you say no?
I don't know.
You don't know?
I was yawning.
Oh, you're yawning? Okay. It's 8:11 and you're already yawning? Too early for that. Okay.
I didn't sleep much last night.
I never get to sleep much because I have to get up so early to be here. Check for the problem. You could check it. If we plug in 1, yeah, we get 2 over 1, which is 2, plus 3 over 1, which is 3, equals 5. 2 plus 3 equals 5, yes? So it checks and it's good. We have done a lot of algebra problems, and I always said before, you could check, but you don't have to check, right? It guarantees that your answers are correct, but if you're kind of confident in your math, then I suppose you don't have to check, and you can just be sure, like, yes, I got it right. For these problems, for the problems we're doing today, you have to check them. For problems like this, where you have an x in the denominator, you can get what's called extraneous solutions. Does anybody know what extraneous means?
They're not normal?
No. Just extraneous. Do we know what extraneous means? Essentially, for the purpose of this, extra. In this case, extraneous solutions are solutions that are not solutions. So far, anytime we got a solution, it worked. For applications, we got rid of negative solutions most of the time, but they all work to solve the problem. Once you start solving problems like this, x is in the denominator, and the other problems we're going to solve later, you can get extraneous solutions, which are solutions that don't work. We haven't talked about functions yet, but it has to do with what's in your domain and not in your domain. And essentially, any x that makes this denominator 0 isn't in my domain, it can't be a solution. So in this case, x equals 0 can't be a solution. When we do the math out, we get x equals 1, so that's okay. Sometimes when solving these out, you will get a solution that if you plug it in will give you 0 in the denominator. That doesn't work, it's an extraneous solution, and you just cross it all out. You only check for the ones that, you check to see which ones work and which ones don't work. Got it? So just be aware, you have to check these. I will go out of my way to make sure to give you problems with extraneous solutions just to see if you're checking them. So, let's do a couple of more. Suppose we have 3 over x plus 4 over x minus 1 equals 5. We have fractions again, we want to clear fractions. What's my LCM? And this is generally the part that gets really confusing for people. What's the LCM of that? Huh? No. Huh? I can't hear you. No. There is actually a trick to this. The one good thing about math and algebra, pretty much everything you learned when you were about 7 still applies now. It looks different, but the math is still the same. That's why they teach it to you. If you had 1 over 3 plus 3 over 7, you would find your common denominator. What's the common denominator? 21. How do you find it? Multiply them together. A lot of times there are other denominators that will work, but if nothing else, multiply them together. Do the same thing here. What are my two denominators? X and x minus 1. So, what's my LCM? Multiply them together. X times x minus 1. Once again, especially for this one, I'll write the whole thing out just so we can see it long form, but once you know what you're doing, you can simplify quicker as you go. You get 3 times x minus 1 all over x, plus 4 times x minus 1 all over x minus 1 equals 5 times x minus 1. Now simplify everything out. X and x cancel here. X minus 1 over x minus 1 cancels here. Nothing cancels there. So you're left with 3 times x minus 1 plus 4 times x equals 5. And here to simplify this, 5 times x is 5x times x minus 1. Get the idea? Now from there, distribute, simplify it all out. We get 3x minus 3 plus 4x equals 5x squared minus 5. Now what type of equation is it? That's an x squared, so it's quadratic. So how are we going to solve it?
Get it all on one side and set it equal to 0.
It's a quadratic, set it equal to 0. The good part about this is you learn basic math in chapter 1. And again, it's math that in this class, I'm sure you've already seen in random algebra classes in high school or even junior high. Solve for x, it's quadratic, set it equal to 0. We look at more complex problems, but they're still based off of the stuff you already know. So here we add a few steps, multiply by the LCM, which is an x, find this bizarre LCM, multiply it all out, simplify it all out, and then it ends up being a quadratic. So then you have to use all the tools for solving a quadratic. Set it equal to 0, factor a quadratic formula, get an answer then. Everything builds. It's awesome. Okay, so for this, 3x plus 4x is 7x minus 3 equals 5x squared minus 5. The square is on the right and it's positive, so I'll bring everything to the right, but then I'll flip it over to the left just because I read left to right. So you get 5x squared, subtract the 7x over, so it's minus 7x, minus 5 plus 3 is minus 2, equals 0. And then just solve that out. I'm not going to take the time to solve that out because all of you can solve it out, right? That's solving a quadratic. That's easy enough to do. And then once you solve the quadratic, you would get two solutions. What would you do?
You
plug both of them in to see if they both work, if 9 of them worked, if only 1 of them worked. But then we're good, right? Okay, good. Then, let's see. How much time do we have left? 5 minutes. Good. That's all we need. 5 minutes for this video. You guys aren't leaving in 5 minutes. A lot more to cover. Okay? Because essentially, this is no different than basic algebra and clearing fractions. You may end up with a quadratic, but that's just solving quadratics, which we've also already done. The only real challenge, if you will, is one, getting extraneous solutions, but that's just checking your work, which isn't a big deal, and you all know how to do that, and finding your LCM, which is the part that confuses people. So I just want to run through 1 and 2, finding the LCM, to see if we can see it and find it. Suppose I have 1 over x minus 1 plus 3 over x plus 1 equals 7 over x squared minus 1. What is my LCM? Anyone? Yeah? If nothing else, what can you do?
X minus 1.
Multiply them all out. If you go term by term, what's x minus 1 times x plus 1?
X squared minus
It's actually this one right here, right? So what's my LCM going to be? X squared minus 1. When you're writing it out, I would suggest, unless you're really clear on what you're doing, write it out in factored form, x plus 1 times x minus 1. Because then you can explicitly see now, to save time, these x minus 1s will cancel. So you'll get x plus 1 times 1, which is x plus 1, plus these x plus 1s will cancel, so you get 3 times x minus 1, make sure it's in parentheses, equals x plus 1 times x minus 1 is x squared minus 1, so the whole thing cancels, and that's just 7. And that you can solve out in about 2 seconds, right? Pretty easy? And then, of course, you would check for extraneous solutions, right? Yes, I'll harp on that because students tend to not do it. Suppose we have one more. Now for the lead. 3 over x plus 6 over 2x plus 5 over 5x squared equals 7. What's my LCM? You can multiply them all together, or essentially look at your constants and your variables individually, find the LCM of both of them, and then combine it. Meaning, for the constants, the coefficients, what do I have? That's a 1, that's a 2, that's a 5. What's the LCM of 1, 2, and 5? 10. For my variables, I have x, x, and x squared. What's the LCM?
X cubed.
You can use x cubed or x squared. Anything will work, right? Lowest power that works is x squared. Anything above that works just as well. There's your LCM. Multiply everything by 10x squared and you're good to go. Get the idea? Think you can do that? Good. Again, I'm not going to take the time to solve these out because the only new thing is finding the LCM, and pretty straightforward trick, and then you're good to go. The rest of the math you know how to do, right? Good. Then I get to end this video and we move on to more stuff.